Now our next job is to determine uh, the parameters that are needed for the transformation. So we have to work out uh, when I equal to 1. So we have to work out the transformation 1 to 0. So for that, how is the red frame related to the frame 0? We will do it uh, in red color. So here we have uh, a 0. Okay. Then we have the link twist, alpha 0. Then we have theta 1. And then we have D. Okay. So these are corresponding to I equal to 1. So let's determine what is A0, A naught. What is this? A naught is the length of the common perpendicular between Z naught and Z1. You see, Z naught and Z1 both are coinciding. So naturally, the length of the common perpendicular is going to be 0. Then alpha naught is a link twist. It's a link twist between Z1 and Z naught. Now you can see both of them are parallel. So there is no twist between these two. So this is just equal to 0. Then the joint angle theta 1. This pertains to the joint 1, theta 1. So look at joint 1, look at Z1. Turn from x naught towards x1. Okay, right now you can see that both of them are parallel. Now if you draw a line which is parallel to x naught, place it here. If you turn from x naught towards x1, you will get the joint angle. If this waist turns a little bit, you will get the joint angle theta 1. But you see this joint angle, it can change. So we will, because it's a variable, it can change. So we will retain it as theta 1. So we'll keep this joint angle as theta 1 itself because it can change with the posture. And D1 is a joint offset corresponding to joint 1. So we have the joint 1 here. It's the offset that you measure from x0 towards x1, and it's from x0 to x1. So the distance that you measure from x0 to x1 along the z axis, z1, because it's corresponding to the joint z1. So the distance that you measure, so it's this length, which I'll just show you. It's the length from here to here. This distance is V1. And you can see in this figure that it corresponds to L1 plus L2. Okay. So we will take this as equal to L1 plus L2. In the same way, we can proceed with the next row as well. So let's do that. So next one is in blue color. So we'll take it in blue color. We'll show this here as A1. Here you are going to take I equal to 2. So when you do that, you get transformation from 2 to 1. That requires these variables A1, alpha 1, theta 1, theta 2, sorry, and d2. So A1 is the length of the common perpendicular between Z1 and Z2. You can see that they are intersecting. So the length of the common perpendicular is just 0. The linguist, well, now these axes Z1 and Z2, they are not parallel to each other, but they are perpendicular to each other. So certainly there is a link twist. And how are you going to measure the link twist? You keep your thumb oriented along x2, turn from z1 towards z2. You can see that it is 90 degrees. So here we will write this link twist as 90 degrees. What about theta 2? For theta 2, look at joint z, look at joint 2, the axis z2. Keep your thumb oriented along Z2. Turn your fingers from X1 towards X2. Right now, both X1 and X2 are coinciding, but the moment you open up your shoulder and go upwards or downwards, this angle will become non-zero. So we will leave it as a variable itself. We'll leave it as, oh, I'm sorry, I wrote here as theta 2. This is wrong. This should have been theta 1. I wish you had corrected me at that time. So this is theta 2. It's the joint angle that is measured about Z2 from X1 towards X2. So this is the angle which it makes with the horizontal, you can see in this case. So we'll keep this as theta. Then we have D2, which is the joint offset corresponding to joint 2. Look at Z2. The distance that you measure from x1 towards x2 along z2, and you can see both x1 and x2 coinciding, they cut at the same location. So even if x2 turns, the point of intersection here will be the same, and this corresponds to 0. So joint offset is 0. Then we have the next one that is in green color. So we'll show this in green color. We have A2, alpha 2, theta 3, and D3. Now, what is A2? It's given as L3.
L3.
Yeah, you're right, you're right. This is L3. What about alpha 2? It's the link twist. Link twist for the link 2. And you can see that if you keep your if you keep your thumb along x2 and turn from you turn from z2 towards z3, here you will get 0. Okay, so it's 0 degrees. And theta 3, you see, this is always 0. That is the reason I am keeping it as 0 itself, because these two axes are parallel to each other. Okay, so along x2, this common perpendicular, it's these two axes are always perpendicular, and they are also having the same orientation with respect to this. So this is equal to 0. Then we come to theta 3. You look at joint 3. corresponding to joint 3. So the angle made from x2 towards x3, keeping your thumb oriented along joint z3. So right now it looks as if it is 0, but the moment the elbow moves, okay, if it moves up, then you will have theta 3 positive. So we'll show this as theta 3. And the last one is D3, which is the joint offset corresponding to joint 3. So focus on Z3. From where x2 cuts it to where x3 cuts it, and you can see that both coincide. So here this is equal to 0. So you have got all the 3 rows. Now each row corresponds to a particular transformation. You can utilize this in the transformation. So first of all, I'm going to show you how to construct the first transformation. You will have to work out the others by yourself. Okay. So we have the transformation from 1 to 0, frame 1 to 0. Okay. So we make use of the first row. So alpha I minus 1 in this case will be alpha 0. And A also AI will be AI minus 1 will be A0. Theta I will be theta 1 and DI will be D1. So in this case, you have cos. So you have cos of theta 1, cos of theta 1. Here you have sine of theta 1 into cos of 0. So we know that this will just be sine theta 1 itself. Okay. Then sine of theta 1, sine of 0. Sine of theta 1, sine of 0. So this will be 0.
0.
So sine of 0 is 0. And here you have the fourth row. We'll show it. And then you have the next column. Can you tell me the elements of the next column? Minus sine theta 1. Here you have cos theta 1, cos alpha, cos alpha naught. I'm sorry, cos, yeah, theta 1 cos alpha naught, right? So cos theta 1 is cos theta 1 and cos alpha naught is cos of 0. So you have cos theta 1. Then next is cos theta 1, cos theta 1 into sine of 0. So here also you will have 0. And here you have 0. What about here? 0 is already present here, so keep it at 0. This is minus sine of 0, so this will also be 0. And this is cos of 0, that is 1.
1.
And here it is 0. What about this?
0.
I minus 1. So here it is A0. So this is going to be 0. Then minus, but because, yeah, so minus sine of 0 into D1. D1 is non-zero, but alpha naught is 0. So sine will become 0. So this will become 0. And here you have cos of 0, that is 1 into D1, that is L1 plus L2. So we'll write this as L1 plus L2. Okay, and the last element here is 1. So we can fix it, we can fit it into this red matrix box. Okay, you can draw the matrix symbol. I'm just making use of a box because it's convenient for me to use graphically. So we have got the transformation matrix T1 to 0. In the same way, the second matrix, the T2 to 1, is obtained from the second row. So here you have T2 to 1. I'm not going to do this, but I'm going to leave it as a homework for you. You have to do it. Okay, please don't hesitate. Uh, don't postpone it, because our subsequent interactions will involve all this. So what is T2 to 1 and what is T3 to 2? T3 to 2 also we need to work out. What are the elements of these matrices? Okay, so these have to be worked out. So please work them out, and this is homework for you.